Good day, everyone. This is the report of Group 3, and we are going to discuss about the nanotechnology. Nano and technology. Nano is a unit of length in a metric system equal to 1 billionth of a meter, while the technology is the making, usage, and knowledge of tools, machines, and techniques in order to solve a problem of or perform a specific function. Definition of nanotechnology. Nanotechnology is the study of manipulating matter on an atomic scale. It refers to the constructing and engineering of the functional systems at very micro level, or we can say it atomic level. A nanometer is 1 billionth of a meter, roughly a width of 3 or 4 atoms. The average human hair is about 25 nanometers wide. The history of nanotechnology. The first ever concept was presented in 1959 by the famous professor of physics Dr. Richard P. Feynman. Invention of the scanning tunneling microscope in 1981 and the discovery of Fluorescence in 1985 lead to an emergence of nanotechnology. The term nanotechnology had been coined by Norio Taniguchi in 1974. The early 2000s also saw the beginnings of commercial applications of nanotechnology. Although these were limited to bulk applications of materials. Silver Nano platform for using silver nanoparticles as an antibacterial agent, nanoparticle-based transparent sunscreens, and carbon nanotubes for stain-resistant textiles. Macro person is equal to 2 billion nanometer. Then the apple is 80 million nanometer, while the ant is 5 million nanometer. While in micro, diameter of a human hair is 75,000 nanometer. Smallest that I can see is 10,000 nanometer, while the coli bacteria it is 20 nanometer. While in nano, buckyball is 1 nanometer, DNA 2 nanometer, diameter of a carbon nanotube is 1.3 nanometer.
The next is timeline. In year 2000, the first passive nanostructures are A, dispersed and contact nanostructures. One of its examples is aerosols and colloids. And B, product incorporating nanostructures. One of its examples are coating and nanoparticles, reinforced composites and nanostructures, metals, polymers, and last is ceramics. And in year 2005, the second active nanostructures is A, bioactive and health effects. One of these example is large drugs and biodies, and B, silicon chemical active, and one of the example is 3D transceivers and amplifiers. And in year 2010, the third is the system of nanosystems, and one of these example is guided assembling in 3D networking and new hierarchical architectures. And in year 2015 and 2020, fourth is molecules and nanosystems, and that's all. Next is tools and technology. There are several important modern development like the atomic force microscope or AFM, The next is the scanning tunneling microscope, or STM, are scanning probes that launches nanotechnology. There are various technology of nano lithography, such as optical lithography, X-ray lithography, and deep pen nanolithography. And the last is electrobeam lithography, or inkjet printer, where are also developed. Lithography in MEMS context is typically the transfer of pattern into photosynthesis materials by selective exposure to a radiation source such as the light. And next is carbon nanotube. Carbon nanotube are allotube of carbons with cylindrical nanostructures. They have length and diameter radio of 132 billion to 1. And nanotube are members of the cylindrical foreign structures family. There are names in derives from the long below structures with walls formed by one atom thick sheet of carbon called graphene. One of its properties is high strength weight ratio, helps in creating lightweight spacecraft, and easily penetrate membranes such as cell walls, helps in cancer treatments. Electrical resistance change significantly when other molecules attach themselves to the carbon atoms, and help develop sensors that can detect chemical vapors. Lastly is the application. Easton Bell Sports on using CNT in making bicycle component, and Zinvex technology using CNT for manufacturing of lightweight boats, and replacing transistor form the silicon chips as they are small and emits less heat in electric couple and wires and solar cells and fabrics.
So I will continue the topic of nanotechnology. So nanorods are one morphology of nanoscale objects. The second is dimensions range from 1 to 100 nanometer. The third is they may be synthesized from metals or semiconducting materials. The fourth is a combination of ligands act as shape control agents and bond to different facets of the nanorod with different strengths. This allow different phases of the nanorod to grow at different rates, producing an elongated object. So this is the uses of nanorods. The first is in display technologies, because the reflectivity of the rods can be changed by changing their orientation with an applied electric field. The second is in microelectromechanical systems. The third is in cancer therapeutics. So nanobots close to the scale of 10 by the power of negative 9. The second is largely in RNG phase. The third is nanobots of 1.5 nanometers across, capable of counting specific molecules in a chemical sample. So the fourth is, since nanorobots will be microscopic in size, it will probably be necessary for very large members of them to work together to perform microscopic and microscopic tasks. So the fifth is capable of replication using environmental resources. The sixth is application. The application of nanobots is detection of toxic components in environment. The second is in drug delivery. The third is biomedical intervention. So approaches in nanotechnology. First is bottom up. In the bottom up approach, different materials and devices are constructed from molecular components of their own. They chemically assemble themselves by recognizing the molecules of their own breed. So examples of molecular self-assembly are Watson Crick base pairing nanolithography. So the second is top-down. So in top-down approach, nano-object and materials are created by larger entities without bouncing its atomic reaction. Usually top-down approach in practice less as compared to the bottom-up approach. So solid-state techniques can also be used to create devices known as nano-electromechanical systems or names which are related to micro electromechanical system or MEMS. So MEMS became practical once they could be fabricated using modified semiconductor device fabrication technologies normally used to make electronics. So the materials used zinc oxide, dirt repellent, hydrophobic, cosmetic, and stain resistant. Then silver ion healing property. Third is aluminum silicate scratch resistance. Gold ion chip fabrication drug delivery.
Application of nanotechnology. So this is the part of innovation application. So first is energy, medicine and drugs, nanobiotechnology, nano devices, optical engineering, defense and security, bioengineering, cosmetics, and nano fabrics. So nanotechnology in drugs or cancer. Provide new option for drug delivery and drug therapies. So enable drugs to be delivered to precisely at the right location in body and release drug doses in a predetermined schedule for optical treatment. Attach the drug to nano-sized carrier. They become localized at the disease site, example cancer tumor. Then they release medicine that kills the tumor. Current treatment is through radiotherapy or chemotherapy. Nanobots can clear the blockage in arteries. So, nanotechnology in fabrics. The properties of familiar materials are being changed by manufacturers who are adding nano-sized components to conventional materials to improve performance. For example, some clothing manufacturers are making water and stain repellent clothing using nano-sized whiskers in the fabric that cause water to build up on the surface. In manufacturing bulletproof jackets, making spill and dirt resistant antimicrobial, antibacterial fabrics. Nanotechnology in mobile. MERP, a nanotechnology concept device developed by Nokia Research Center or NRC and the University of Cambridge, UK. The MERP will be super hydrophobic, making it extremely dirt repellent. It will be able to charge itself from available light sources using photovoltaic nanowire glass covering its surface. Nanoscale electronics also allow stretching. Nokia envisages that a nanoscale mesh of fibers will allow our mobile devices to be bent, stretched, and folded into any number of conceivable shapes. So, nanotechnology in electronics. Electrodes made from nanowires enable flat panel display to the flexible as well as thinner than current flat panel displays. Nanolithography is used for fabrication of chips. The transistors are made of nanowires that are assembled in glass or thin films or flexible plastic. E-paper displays on sunglasses and map on car windshield.
So now I will continue the topic that is all about nanotechnology. Nanotechnology in computers, the silicon transistors in your computer may be replaced by transistors based on carbon nanotubes. A carbon nanotube is a molecule in form a hollow cylinder with a diameter of around a nanometer which consists of pure carbon. Nanorods is a upcoming technology in the displays techniques due to the less consumption of electricity and less heat emission. Size of microprocessors are reduced to a greater extent. Researchers of North Carolina State University says that growing arrays of magnetic nanoparticles called nanodots. Hewlett-Packard is developing a memory device that uses nano-coated with titanium dioxide. One group of these nanowires is disposited parallel to other group wires at its intersection. A device called memristor is formed. A memristor can be used as a single component memory cell in an integrated circuit. By reducing the diameter of the nanowires, researchers believe that memristor memory chips can achieve higher memory density than flash memory chips. Magnetic nanowires made of a alloy of iron and nickel are being used to create dense memory devices. Chips produced by Intel before I-series process will be 65 nanometer to 45 nanometer. Later, with the help of nanotechnology, 22 nanometer chips will made, which itself is a milestone. So, advantages of using carbon nanotubes: faster and smaller. Carbon nanotubes can be used to produce smaller and faster components. This will also result in computers that consume less energy. High speed and high capacity memory allow circuits to be more accurate on the atomic level. Other uses: cutting tools made of nanocyclitylene materials such as tungsten carbide, tantalum carbide, and titanium carbide are more wear and erosion resistant and last longer than their conventional counterparts. Silver nanocrystals have been embedded in bandages to kill bacteria and prevent infections. Nanoparticulate-based synthetic bone, formed by manipulating calcium and phosphate at the molecular level. Aerogels, lightest known solid due to the good insulating properties, is used to spacesuits and are proposed to use in spacecraft. Possibilities for the future: nanotechnology may be make possible to the manufacture lighter, stronger, and programmable materials that require less energy to produce than conventional material, and that promise greater fuel efficiency in land transportation, ships, aircraft, and space vehicles. The future of nanotechnology could very well include the use of nanorobotics. These nanorobots have the potential to take of human tasks as well as tasks that humans could be never complete. The rebuilding of the depleted ozone layers could potentially be able to be performed.
Pitfalls of the nanotechnology. Nanoparticles can get into the body through the skin, lungs, and digestive system, thus creating the free radicals that can cause cell damage. Once nanoparticles are in the bloodstream, they will be able to cross the blood-brain barrier. The most dangerous nano application used for the military purpose is bomb that contain engineered self-multiplying deadly viruses that can continue to wipe out of the community, country, or even a civilization. Nanobombs, because of their reflecting behavior, can be big threat for the gray go.